just think about a particular web browser. You are trying to browse a particular website, flipkart.com, and you also have a mobile app on the Android Flipkart, and then you will also have on iOS or something, right? And that is where the user will log in, right? So your browser is here, your mobile app is here, and then you try to access the Flipkart app or website. So as I was telling, right, so first thing it will do is it will do a DNS lookup. It will get the a list of all the load balancers and everything, right? And then it will call your load balancer. So the load balancer's IP will be hit by the browser or the mobile app, and then the load balancer will decide that which particular server 1 or server 2 or server 3 or server 4, how many servers you have, will serve the traffic from. Now these servers are owned by Flipkart. So this is server 1 and server 2, where the Flipkart's code, maybe you have written in Spring application, your application Spring application is actually hosted on this particular machine. Okay, so server 1 and server 2. Now the load balancer will basically redirect the request to the server 1, and then server 1 will need to make a DB call to get the product details. Then it will make a call to the DB, and it will go to the read will go to the slave. As I was talking about, this is one of the master slave design, where all the write request will go to the master database and the read will go to the slave database. So if it's a read, if it's a get request, it will go to the slave database and it will get the details and it will serve to the server 1. Okay, now just for a time being, just don't ignore this cache. Okay, so your traffic has been served, and then it has basically took the product details and it returned to the load balancer and forwarded to the web browser, and you're able to see the product details. Same thing on the mobile app. Now, what is this CDN I was speaking, right? So when you are visiting a website, you might be seeing that a lot of banners, image, a lot of flashing things, and also there are a lot of videos. All these contents keeps coming, right? And those are quite heavy. Now, quite heavy means the size of those data are quite huge. The CSS, the HTML, if you guys have worked in UI, you might have understood that, the node modules, the node module size itself is in sometimes MBs or GB. Now, there are CSS and HTMLs, which are quite huge, the JS files, the video files, they are like MBs and all, right? Now, just assume that, you are making a request and then it goes to load balancer and from the server to the database. And if you're serving those data from the master database or the slave database, see the network hop. Your database is in one IP address. From this to this another IP address, there will be one network hop. There will be latency of transferring of 10 MB of data from here to here, then here to here, and then finally it reaches. So there are 3 or 4 network hops are there in order to read that data. Now, if we try to get the videos from such way, it is going to take a longer time in order to show or display on your website. And that is where the CDN comes in, right? The CDN, basically what it helps you is that it will simply say that, hey, these are all non-protected data. It means that it's publicly accessible and you can generally, just a lot of data are without authenticated. You can just simply go and guess the HTML because there is nothing user specific data will be there in the CDN. It will be like HTML, images, videos, non-restricted videos and all that. And what will happen then is it will serve those data directly from here to there without any intermediary hops. Okay, so and also the another point, as I was speaking, these are geographically near to you. That is the major advantage. So Flipkart might be hosted in Singapore, your database might be hosted in somewhere, and then those network hops will create a latency. So to avoid those latencies also, we use the CDN. So this is fine. This design will work, whatever the problem we are trying to solve. But suppose there are, as I was speaking about the browsing of the data, right? A lot of times we just simply go and check, hey, you bought this phone. How's it like? You say, hey, I got in, this rupees, and then what you do is simply just go and browse it. Hey, I think the price has changed, and then simply you just browse, and you're not even interested in buying that, right? So those kind of traffic is called the browse traffic, right? So they don't want to invest more energy in more resources, more money in browsing data, right? Because you're not actually buying things, you're just browsing it, right? So those are non-transactional data is what they call, right? So those data should not make an expensive call to DB. The DB is expensive call, it's expensive resource. So you should be, careful about, making a request to DB, right? So what they do is non-transactional data, right? When you're on browsing page or something, instead of making a DB call, they will first hit the cache. So cache is basically Redis cache is one of the famous, then Couchbase DB, there are a few various famous distributed cache are there, and they check in the cache whether cache is there or not. If it is in cache, it will directly serve it from the DB, from the cache. And if it doesn't find, so if it's a miss, it will make a DB call and it will get the data from the DB, it will update its cache and return to the server. So that way what we are doing is we are separating the non-transactional and transactional data, so that because see, the master database or the slave database will be used for the ordering purpose. When you actually go on the checkout page or you go on the payment page, those are quite critical places where you need to be extremely low latency applications, so that you don't give any second to the user to think about and change the their decision. So there has been a survey where people have done that. They understood that if you do 2 seconds of or 1 second of latency in the item checkout page, people drop the idea to buy, because that is the window you get to make them buy things or drop the idea, right? So that is very crucial place, right? So you don't want to waste your CPU cycles or DB calls for non-transactional where people are just browsing, and that is where the cache comes in place, right? You just serve the traffic and then they say that, okay, it's 900 rupees, and then you actually interested in buying, then you click on buy now, and that's when sometimes you might be seeing a refreshed amount, and that's when you say the price has changed or the delivery time had changed or whatnot, right? What are the data which is required for placing an order, right? So this is one of the most basic design any application must have in today's world. Okay, so this is what we should be starting with, and then we'll read more and more about each and every component, how we can fit in, and then what we are going to do is we'll take a lot of different problems like tiny URL, rate limiters, then we have various like designing a YouTube or live streaming, right? Designing a particular tweet feed, how we are going to do, what are the things we are use, when to use, what not to use.